Imagine a world where we waste one third of all the food we produce, while at the same time there are 2 billion people who are suffering from hunger and undernourishment. It's a paradox that has plagued our society for decades.
But what if I told you that we now have the tools to bring about a change? Hi, my name is Aisha, and in this video presentation, I will be presenting a project that explores the potential of artificial intelligence and machine learning to achieve zero waste, and which is also aligned with the UN Sustainable Development Goal 12, responsible consumption and production.
As a child, I always wondered what happened to all of the food that wasn't bought at the supermarket. Little did I know that this is just one aspect of a global problem that affects all of us. Through this project, the aim is to use AI and machine learning to tackle food waste in retail, which is a significant contributor to the problem. So, why retail? Well, the United Nations has identified it as a crucial target for achieving Sustainable Development Goal number 12, which is responsible consumption and production. Retail plays a crucial role in achieving this target as it is a link between producers and consumers and thus has a significant impact on consumption and production patterns. The modern retail industry, with its large scale operations and global supply chains, has contributed significantly to the problem of food waste. Hence, the UN has identified retail as a target sector for promoting responsible consumption and production patterns.
Join me in the rest of the presentation as we explore how we can leverage technology to pave the way towards achieving zero waste and responsible consumption and production.
In a recent conversation with a senior executive at Canada's biggest retail chain, we learned that despite having the best technology at their disposal, a significant amount of non fresh produce is still going to waste. The root cause: products are often pushed back on the shelf, and the company's lack of sustainability measures worsens the issue. This is where AI comes in. By leveraging machine learning algorithms and data analysis tools, the attempt is to optimize store operations, reduce waste, and improve profitability. Say goodbye to inefficiencies in shelf management and inadequate demand forecasting. Inventory management. This refers to the process of managing the stock of goods or materials that a company holds. The primary goal of inventory management is to optimize the balance between inventory investment and customer service levels. Inventory forecasting. In this layer, we will use XGBoost, a machine learning algorithm for demand forecasting. By analyzing past sales data, market trends, and other factors, inventory forecasting can help businesses estimate how much inventory they will need to meet the customer demand in the future. The goal of inventory forecasting is to reduce the risk of stockouts and overstocking. Inventory control. In this layer, we will use a dynamic pricing model based on the random forest algorithm and expiry dates to manage inventory levels. Inventory control aims to prevent stockouts, overstocking, and excess inventory, which can result in increased holding cost, lost sales, and decreased profitability. Inventory analytics. The last layer involves using data analysis techniques to gain insights into inventory performance. The goal of inventory analytics is to provide businesses with a comprehensive view of their inventory performance and help them make data driven decisions about their inventory management strategies. To forecast demand and replenish inventory, we'll use the XGBoost. It is a powerful and popular gradient boosting algorithm that is commonly used for regression and classification problems in machine learning. It works by building an ensemble of decision trees iteratively, where each subsequent tree tries to correct the errors of the previous tree. It uses a combination of regularization techniques such as shrinkage and pruning to prevent overfitting and improve generalization performance. So we start by collecting and preparing historical data. We extract meaningful features and train an XGBoost model to predict the future demand. Once the model is validated, we can use it to forecast demand and optimize inventory management by identifying the best time to order and the optimal order quantity. In addition to this, with the help of our automated inventory management system, businesses can easily identify items that are close to expiry and set an appropriate discounted price for them. This information can then be made available in a user friendly dashboard, allowing businesses to quickly take action and avoid potential losses. This can also help to increase customer satisfaction by offering discounted prices on items that would otherwise go to waste. Seasons, holidays, and other trends can have a significant impact on demand for certain products, making it important for businesses to consider them in their inventory management strategies. By analyzing historical data and market trends, businesses can make informed decisions about which products to stock and how much of inventory has to be kept on hand. Random forest is a popular machine learning algorithm that can be used for regression and classification tasks again. Using a random forest regressor, businesses can build a dynamic pricing model that can help them find the optimum price point for products. By analyzing various factors such as consumer demand, competitor pricing, and seasonal trends, the model can predict the most profitable price point for a particular product at any given point of time. This allows businesses to adjust their prices in real time, maximizing revenue and profitability. With the help of a dynamic pricing model built using a random forest regressor, businesses can stay competitive and responsive to market changes. In conclusion, implementing effective inventory management strategies such as identifying items close to expiry and using dynamic pricing models can help businesses increase sales while reducing food wastage. By optimizing inventory levels and pricing strategies, businesses can sell more products, reduce waste, and improve profitability. This not only benefits the business but also contributes to environmental sustainability by reducing the amount of food that goes to waste. Therefore, it is important for businesses to prioritize efficient inventory management to achieve both economic and social benefits, where an increase in sales is directly linked to the reduction of food wastage. Demand forecasting using XGBoost. This code performs exploratory data analysis and creates a regression model to predict sales based on different features. Here's a breakdown of each section of the code. Feature engineering. This part of the code creates new columns for year, month, day, weekend, holidays, weekday using the date column. It splits the date column into year, month, and day columns and converts them to the respective data types. It also creates a new column for weekend and holidays by applying a function to check whether a given date is a weekend or a holiday in Canada. Exploratory data analysis. This part of the code creates various visualizations to explore the relationships between different features and sales. It uses bar charts to compare the average sales across different features such as store, year, month, weekday, and weekend. It also creates a line chart to show the average sales across different days. Additionally, it calculates the simple moving average of sales for a window period of 30 days and plots it against the actual sales data to visualize the trend. Data preprocessing. This part of the code drops the date column and removes outliers by filtering out sales values greater than 140. It then separates the features and target variable into separate data frames and scales the featured data using standard scaler. Model training. This part of the code defines 4 regression models. linear regression, XGBoost regressor, lasso regression, and ridge regression. It trains each model on the training data and evaluates performance using mean absolute error on both the training and validation sets. Finally, it prints the training and the validation errors for each model. Expiry date module. This code snippet provided is an expiry date module which calculates the discount percentage based on the time difference between the current date and the expiry date of a product. It is used in inventory management to keep track of the expiry dates of products and offer discounts on products that are close to expiry to avoid wastage of inventory. This module uses the datetime library to convert the expiry date and current date strings to datetime objects, calculates the time difference between them using time delta, and determines the discount percentage based on the time difference. The module then prints a message indicating the product ID, the discount percentage, and the number of days left for the product to expire. This module can be used in conjunction with other inventory management modules that keep track of the stock levels and sales data to optimize inventory levels, reduce wastage, and maximize profits. By offering discounts on products that are close to expiry, businesses can increase sales and reduce inventory holding costs. Dynamic pricing module. Here are the following steps. Data loading and preparation. Firstly, we load the necessary data for the analysis. We then clean it and add any additional data needed. This may include data on products, prices, discounts, dates, and quantities sold. Data aggregation and encoding. Secondly, we group and aggregate the data to create a sales by data and category table, which has the total quantity sold, total sales amount, average discount, and average item price. The product IDs are then encoded with numbers using a dense label encoder to allow for modeling. Model fitting and prediction. Thirdly, a regression model. Here, a random forest regressor is fitted to predict quantity based on product, discount, price, day, and month. The model is then used to predict the quantity based on the data, compute the mean absolute error, and print the error. Optimization function. Fourthly, a function is used to perform the optimization. This function creates virtual products with random prices and discounts and has the model predict the quantity that would be sold with each combination of those parameters on a given day, month, and product. Parameter optimization. Fifthly, the time period and product or category to optimize are chosen, and the optimization function is run to get the optimal parameters for price and discount. Visualization. Finally, the results are visualized using Plotly Express and Plotly Graph object modules. The final graph gives the optimal price point. Here in the graph, it says that the optimal point is true. The item price is 19.66, the discount percentage is 0.26, and the QR prediction is 14.7. As we move towards the end of this presentation, let's look at some of the conclusions and implications. Inventory forecasting. This can help businesses estimate how much inventory they will need to meet customer demand in the future. By using machine learning algorithms such as XGBoost, businesses can reduce the risk of stockouts and overstocking. Inventory control. By using dynamic pricing models based on machine learning algorithms such as random forest and expiry date tracking, businesses can optimize their inventory levels and minimize wastage of inventory. This can result in increased profitability and customer satisfaction. Inventory analytics. This can provide businesses with a comprehensive view of their inventory performance and help them make data-driven decisions about their inventory management strategies. Dynamic pricing. By using a combination of data aggregation, model fitting, parameter optimization, and results visualization, businesses can identify the optimal price and discount points that can result in increased sales and profitability. Effective inventory management. Overall, effective inventory management can help businesses minimize their inventory holding cost and help businesses stay competitive in their respective markets. I hope that you have found this presentation informative and inspiring, and that it has encouraged you to consider the ways in which you can contribute to the fight against food waste in our own workplaces and beyond. Thank you for joining me today and being part of this solution.